We are live. Hello, guys. Thank you so much for joining us for this other chapter about the VJUG Book Reading Club session. Uh, Today, we're going to start with a new book, the book that you actually pick from our pools. Actually, I have it right here. So we're going to talk a little bit from this book wrote by Tony Bevis about Java design pattern essentials. And my name is Roberto Cortez, and we have with me Ivan and Venkat. So please introduce yourselves.
Hi there, my name is Venkat Subramaniam, consultant, programmer, author. That's pretty much.
Okay, so my name is Ivan Ivanov, and I'm part of the VJUG team helping Roberto with the book reading club.
We also have Tony here with us a couple of minutes ago, but he disconnected, so hopefully he could join us later. Let's see if he can figure out the issues and join us again. So Ivan, I know that you have a couple of questions regarding some of the things that we have on the book. Do you want to start throwing them?
Yeah, actually, we'd like to encourage our audience to ask the questions in the chat. But since we know that some of you are a little bit shy, and since we don't want to lose time in order for you to type your questions, I have prepared a few of them for our guests, or for Venkat for now. Hopefully Tony is able to join in a minute.
Yes, guys. So remember that we have an RC channel, so join us there, and you can ask pretty much any question that you want from the book or any other question related with the topic that we are discussing. So please send them, and we were happy to relay them to Venkat or either Tony, or even us can answer them. So please collaborate. But go ahead, Ivan.
Today we are discussing the first two parts of the book, which are the creational patterns and the structural patterns. They are basically the same as those patterns in the Gang of Four book. But I will start with something else. So it's again kind of a pattern which I was taught some 10 to 15 years ago by the senior developers in my team. So I was taught then that I should code always to interfaces. I should have first create an interface and then the concrete class, even for simple Java beans with getters and setters. I guess that this comes from the C programming influence, where you had header files for everything. But still, Java E was also influenced with this, with the heavy use of local interfaces, remote interfaces, and so on. But now we see a kind of a different aspect on this. So no one codes so much against interfaces. Even in Java world, they are not required. Of course, you can have them, but they are not required. So my question to Venkat and to everybody here is, when would you use today interfaces in Java?
Well, I think that's a very important question, and oftentimes we get into the situation where software design, architecture, everything really comes down to trade-offs. And one of the problems is enormous amount of complexity that we introduce in applications. And the more complexity we have, the more difficult it becomes to maintain applications. So on one hand, the designs that we create must solve real problems that we have without really taking us to this accidental complexity. So in that regard, I will call upon two things here that might help us. One is recommendations by Kent Beck, and Kent Beck says it's better to triangulate rather than creating abstractions to begin with. And I'm a huge fan of that particular approach. And what triangulation means is you go ahead and create an abstraction, but when you see that there is another abstraction that you need, which is very common to it, you want to then abstract the commonality up. That might be an abstract base class. It could be an interface. That's one thing. On the other hand, The other thing I want to mention is called the Postel's Law. Postel's Law says, be very generous about what you receive and be very, conservative about what you send. And in the API design point of view, what that means to me is a list, and if you want to send me a linked list, we're going to be in trouble. Then we could say, why don't I receive a list interface, and even go to the extent of collection, or even raise it up to maybe an iterator. Well, then if I receive an iterator, you can send me a set or a list or just about anything that can be iterated upon. So there is this tension between these two things. And the short answer is there's no really right one answer. My recommendation is start with what works, what is simple, and only create interfaces and abstraction when it provides true value so we don't get into accidental complexity.
That's great answer, especially for the junior developers that are here in our audience.
Let me ask you something else regarding still this topic. So, looking into how Java 8 introduces the new default method interfaces, do you think that this changes anything on how we should use interfaces on Java 8?
No, I don't think it does, and the reason is, if we apply the law of triangulation and say we are going to only raise commonality when we need it, we don't then jump into creating interfaces right off the bat. So I see almost everything, including default methods, as tools on our hand, and we have to be extremely wary and careful about using these tools. And if we arbitrarily use these tools, especially the newly found tools, arbitrarily, I think we end up with complexity than real good solutions. So definitely default methods, I like it. I'm not going to say I don't like it, but it's not a tool that I would jump into. I would evolve the code towards it rather than start with it.
Okay.
Cool.
Good. Anything on chat, Roberto?
Not at the moment, so you can still ask some of your questions that you have there.
Okay. So, Venkat, I was at your talk at Java 1 about implementing patterns in Java with lambdas. I don't exactly remember the title, but I guess you know which is that. So this was really good and interesting talk, at least to me. I'm sure you always have your examples with code, your code samples with you. So I liked very much how you implemented decorator pattern in the light of the new things that come with Java 8. So would you please share with us this new approach that you show to the audience at Java 1?
Sure.
And maybe tell us how it is better than the original approach.
Yep. So let me go ahead and share my screen if you don't mind, and then you can confirm to me if you're able to see my code. So let me see how this works. All right. So at this point, you should be able to see the code. Can you confirm?
Yes.
Okay, excellent. So if you really look back in time, ask almost everybody, what do they remember about decorator pattern? And what we remember is this scary little thing that's somewhat like, buffered input stream, and then file input stream and stuff like that, right? So things that can keep going on like this. With all these new, well, that's a lot of ceremony, that's a lot of noise, and so many objects we are creating, and it becomes really bulky. Well, with lambdas, we have a few interesting things we can actually use. But the very first thing is, lambdas have this wonderful thing where we can combine functions together. So if you were to bring in a function, for example, if I say, let's say in this case, a function of integer and returns an integer, let's call it as increment equals, and then given an element, I want to go ahead and increase the value of the element. And likewise, I can come up with another function here, and this function says, let's say, double it, and then in this case, it's going to say, given an element, double the element. Well, what I can do here is I can say apply, and we can provide, let's say, a value 5. Well, this is going to take the value 5 and increment it. But we can roll this into a little function. So for example, we could say, let's say, use function, and I'm going to pass, let's say, a value and pass a function which is going to take the integer and return an integer, and we'll call this as func. Well, the beauty of this is I can do the same thing here. So func.apply and then pass the value to it. So we can call this function here, and we can say, for example, use function, and then let's say 5 and then inc, and we are asking it to increment the value. We can also say use func, and we can send the same value 5, but we can ask it to double it. But here comes the charm. We can nicely combine these now. So if I wanted to increment and double, I don't have to do something silly like this, like a temp equals, and then increment dot, let's say, apply 5, and then I don't have to say, for example, double it dot apply temp. These are garbage variables, but I really want to directly go through and use this idea to get this value of 12. I can simply say use function, and then in this case, increment, and then, and we can say double it. So this becomes a very nice way to combine these two operations. In a very similar way, we can say 5 comma increment and then compose and double it. Well, this is going to first double the value, so 5 times 2 is 10, and then increment it to give us a value of 11, and you can see how that's able to do that as well. So this is a little feature we can quickly exploit. So what we can do is we can use this feature to build on a decorator very nicely and very quickly. So what we can do in this case is we can take a series of functions. So I won't go through the full code example here, but I'll just give you an example of how we can do this. So if I have a function here, let's say, of integer and integer over here, and let's say this is going to be our operation, well, what we can do here is simply we can say, well, I want to combine these operations. So we could say, for example, combine, and the combine function can take a function which is integer comma integer, but I'm going to send a var arg of it. So we can call it as operations. And within this, what we can do is we can say something extremely concise like this. We can say operation equals, and then stream of operations. So because this operations is an array, we can create a stream from the array using the off function. And then what we can do here is we can call a reduce function on these collection of operations. And the very first thing I can do here is to start with, if there is no operation available, I can say whatever is your input, return the input for me. And the second function in this case could be that provides me a way to combine this. So I can say, for example, if I get a function on my hand, so we could say operations, so we can say funcs, comma, a particular function, and I can return, in this case, funcs dot, and then I can say and then, and add the function to it. So this could be a way to start combining it. But once we get a handle on what this means, we can replace the very first one here with functions.identity, and then we can replace the second one with a method reference very easily to make it extremely concise. So this becomes function and then, and we can start combining with that kind of function. So this becomes a very nice way to take these little functions and then put them together as a series of functions for us to use. So how would this really help us? Well, the way this is going to help us is if I create a sample, let's say, equals to new sample, and then I can on this object say sample dot combine, and we can start decorating these things. For example, in this case, I can say increment is the function that I want to send, or even better, we can say sample : inc, where that could be a function, let's say in this case, where I have an inc function, which is going to take element and let's say return element plus 1. So we can start combining these functions into these kinds of operations. Then we can call, use function, for example, public void, say, do work. And what this function can do is it can simply say, oh, let's say output operation.apply, And this could be simply, let's say, take a value of 5 and apply it. So what we're doing here is, once I combine it, I can say sample.doWork, and we can start combining these operations together to produce a bigger operation. Well, it's giving us a little warning. Ignore the warning for a minute. Let's go ahead and bring in the stream in this case. So I'm going to bring in the stream and dot star. So what we're doing in this case is we're combining this into java.util.stream, of course, spelling. So we're bringing this particular function and combining it. So what's the benefit of this operation? Notice the value of 6 in the very end, but here comes the beauty. I can now start decorating with these functions. So if I have a double it function right here, where I'm going to double the value, well, I can now start applying a decoration of these by simply saying comma, and then we could say double it, for example. So you can see in this particular case, the result is a 12, and the reason is we took the value, incremented it, and then we doubled it. Or we can also, rather than doing that, combine in a different manner also. So essentially, these become nice little decorations. And in this case, I'm going to say sample and increment. So to me, lambdas give us a really elegant way to start. You can see the result is 11 here. Really elegant ways to start combining things together. So you can start creating functions rather than classes, which become these little decorators. And then you can start decorating by putting a series of functions together. And that is a very lightweight approach compared to that scary little new that we used to create to go through the objects and work through it. So to me, that really is pretty exciting in terms of how we can actually do that.
Awesome.
Okay.
Thank you so much. That was an awesome explanation, Venkat. Before going to more questions, we actually have Tony that was able to join us. Hello, Tony.
Hello,
Can you hear us?
hello, Roberto and everybody. I apologise, my internet connection dropped out. It took ages to get back, so hopefully it holds up for the rest of the stream. But if it does drop out, I've just got problems here. It seems at the moment. So
yeah, usually these things always happen when we need to do some kind
right on 5 o'clock.
Yeah.
Decided to drop. Typical.
So we have to start because we were going late already. Can you please introduce to the audience since you just joined us?
Yeah, sure. Well, my background has been in software development for many, many years, really. I started as a trainee programmer back when I was 17 years old on a mainframe, a Sperry Univac mainframe, using a language called RPG2. Since then, I've done all kinds of things. But most recently, I do a lot of Java programming, a lot of PHP programming, developing corporate websites. I also work as an associate lecturer for the Open University in the UK. That's a part-time role. So I've got lots of things going on. Yeah. So then did Java many years ago. Did the patterns book originally in 2011, did a second edition a couple of years later, translated it into C# and to PHP, and also did a more introductory Java programming book as well. So that's where I'm at the moment. Okay,
cool. Can I ask you what were your motivations to write this book? I actually have it right here.
Yeah, sure. Well, we got the daddy of them all, which is the original Gang of Four book, which is an excellent book in its own right. But from a Java programmer's perspective, it's not Java. And also I felt that some of the examples were a little bit, took a while to get your head around. They kind of distracted from the pattern by introducing things like mazes that weren't really as simple as they could be. So I felt there was a need for it. There, of course, was the Head First Patterns book in Java, which I think is a pretty good book. It's quite a heavy book, though. I haven't read it for a few years, but I think it's something like 500-600 pages, and it only covers, I can't remember exactly how many patterns, but certainly not all of them. And I felt there was a need for a book that was a just concise introduction that went through all the Gang of Four patterns, plus a couple of extra ones that are heavily used, and just laid it out in a easy to use, let's get you started, but also as a quick reference for when you know it and you think you can't quite remember how does that look together. You can look it up. So really one for beginners, but also for a quick reference, and just keeping the examples as simple as possible, or still doing something that's kind of meaningful and real world.
Yeah, there was a question in our group today about the difference between the two books, your one and the heads first design pattern. So basically, is it the main difference that you just outlined?
Yes, I think so. I think the head first pattern concentrates on, I can't remember how many, maybe half of them, maybe slightly more than half of them, and it uses examples which are simple, but perhaps not quite as real world. Things like, I don't know, bubblegum machines or things like that. So I also wanted to have a common theme running through all of my patterns. So they all work on this fictional motor manufacturer and the construction of cars and vans, and the different types of things that you might need to programming and how you can apply a pattern to help solve that particular problem. And also my books are a more lightweight read. I think it doesn't go into lots of nitty-gritty. It avoids discussions over things like whether or not a singleton is a good pattern to use. It kind of presents, here's where you can use it, and then leaves it to you as a tool that you can use, rather than getting boiled down into, is it good, should you avoid it? I take the view that all of these things are just tools. It's a tool in your toolkit. You can use it where you think it's going to help you solve a problem.
Okay. Cool. So, are you planning to write like a third edition of the book for Java 8?
It's not currently in the pipeline. I've got too many other things going on. I wouldn't rule it out. Yes, certainly if a third edition happens, I would relook at every single pattern in the book. I think one of the questions that might have cropped up is, will I look at other approaches of doing things? Absolutely. So yes, if a third edition does come along, every pattern will be reviewed to see whether there's a clearer, better, more modern way of doing it.
Yeah, that was one of my questions. I had a question about the builder pattern.
Okay.
Yeah, the way that I mostly see it implemented today in the JDK API, mainly, but not only there, is slightly different than the way that you have explained it in your book. Most
Yes.
Probably your book its roots are in the original Gang of Four book.
Yes.
So yeah, my question was really, are you going to, if you write a third edition of your book, or if you had to write the book now, would you revise some of these patterns?
Absolutely. Every single pattern, as I said, would be reviewed to see whether there's a better, clearer way of accomplishing things. Because like everything, patterns evolve. Just as our programming skills evolve. So yes, I think there are always better ways. Singleton's a good example because in the first edition I just concentrated on the classical way of the singleton of a private constructor and then public static members. But then in the second edition I introduced this alternative using enums. So yeah, I think there's scope in every pattern to review it and say, yes, I think there's a better, more modern way of accomplishing this, or maybe not necessarily better in all cases, but perhaps better in some cases. In other cases, the classical approach might be better.
Okay, so we actually have a question a little bit related with coming from our audience. So this is a question from Eka, I think that's the right pronunciation. And he's asking if the functional programming replaces the original Gang of Four design patterns.
I think it's more complementary to it rather than replacing it. There are some nice things in functional programming that make your life easier, but that doesn't mean you're replacing it. You'll just use it. Again, I'm coming back to this idea of thinking about tools in a toolkit. it's a tool that you can use. Pick the best tool to solve your problem. If it's using functional programming as the best tool, do that. If it's using a classical pattern, do that. I think every situation is going to be unique, and so pick the right tool, the right pattern, the right method, for the right functional procedure for the job that you're trying to solve. They complement each other rather than replace each other, I think.
We also have another question here, and it is like usually one of the most asked questions around, probably on the web as well, regarding design patterns is, when it's okay to use the Singleton pattern?
Okay, well, if you one way that you can use it legitimately, I feel, is if you in combination with the facade pattern. So imagine that you have an application that you've broken down into various layers, and you might layer your application into separate packages. So one package might deal with sales processing, one package might deal with order fulfillment, one package might deal with purchasing. Each of those packages is going to have a multitude of classes in it, and you could very easily fall into the trap of having each classes from one package talking to multiple classes from another package. So what can help there is a facade class in each of those packages, which is like a single point of entry. Now, for a facade to work, you only want one facade in each package, so that a class from package A talks to the facade in package B as a single point of entry to that package. So that facade class should itself be a singleton. And then the facade class takes care of simplifying the complexity behind the scenes of that particular package. So there's one example where I think Singleton has a legitimate use. And I think there are other examples too, but admittedly it's easy to fall into a trap and overuse things and use things where they're not intended to be used. But nonetheless, I do think, like anything, it's a tool. The Singleton is a legitimate pattern, in my opinion. Use it where it solves your problem. Don't use it for you don't want to use it for your global constants or things like that. That's not what it's intended for. But it has legitimate uses, I feel, in certain situations.
Sure, I've also heard about good singletons and bad singletons. So.
Okay. So probably going to deviate a little bit on our conversation because Venkat, are you still with us?
Yes, I am.
Awesome. So I'm going to deviate a little bit because we have a couple of members that are not really familiar with lambdas and functional interfaces. So do you mind in using your magic and explain us in in an easy way what the functional and a lambda is?
Sure. I'm assuming you're able to still see my screen.
And you can use the code as well. Yeah, I'll change to your screen.
Okay. So
there you go.
So what I'm going to do here is just to kind of illustrate just one quick example about what this actually means. This actually is fairly simple because we in Java have gone through a lot of pain over the years. So think of this as a pill that it leaves us that pain. So for example, thread, we've done this several times. Every programmer who's ever done Java code has done this. And I'm going to say, thread.start, and I'm going to, in this case, say in main. Well, this obviously is a little code running in the main thread. But we have done this before. We say runnable, and then within this we would say public void run, and then here we would say, let's say, in another thread. So in this case, this another thread obviously is going to run in a secondary thread that we just created. We can see the sequence here, which I left out having the sequence in this order. So you can see that in main printed first, and then this other thread kicked in, and we can see another thread. But if you notice, I was actually reading somewhere, and somebody pointed out to me that this person has been programming in Java for 2 decades, but never felt a need for passing a function to a function. And that surprised me because Java has introduced so much ceremony we don't even realize what we've been doing, with so much, trouble these days, these years. So if you really look at this code, we call this as anonymous inner class, but our real intention was to really pass that one line of code to the thread and say, could you please take this and run elsewhere? This could be one line of code. It could be a function rather than being one line of code. I'll come back to that in a minute. So in this case, rather than all this ceremony, we can simply get rid of that noise and simply put an arrow. And so all that a lambda is an anonymous function. That's basically what it really is. So this becomes an anonymous function. So typically a function has a name, a parameter list, a return type, and a body. Well, we got rid of 2 of the 4 here. We don't have a name, and we don't have a return type. We have a parameter list, and then we have the body of the function being given here. Or alternately, if you had a run function, run interface earlier, as we did, what do we typically do here? Well, we might come here and say, do work, where do work may be that other function I'm really interested in doing. So in this case, I could say do work, and the do work function is going to do whatever that work is. So we'll say actual work in another thread. So in this case, of course, we are calling the do work. Again, we don't have to incur so much pain. We can get rid of all of that noise, and we can simply say sample right here, and then call the do work. So the idea behind this is we can pass a function directly to another function, in this case the constructor, rather than having to create an anonymous inner class. So essentially this gives us the ability to pass functions around. So this takes us from a concept where we did what are called normal functions. These received objects or primitives, and now we are saying we're going to use not normal functions but higher order functions. So what are higher order functions? These can receive, in this case, we can receive, not only objects, not only primitives, but they can also receive other functions as well. So we are able to pass functions to functions. Likewise, or return functions as well. Much like how we were able to return objects and primitives from normal functions, we can return functions as well now. So essentially, functional programming at the very first level gives us higher order functions, so we can pass functions to functions, and rather than just focusing on object decomposition, we can use function decomposition as well.
Awesome. I think our members are going to be very happy with your answer. I think it really nailed the functional explanation about lambdas and anonymous functions. Actually, now we have a question from, let me see, RZNZ. This is for Tony. So actually, RZNZ didn't quite understood why does the facade class needs to be a singleton?
Because when one package is talking to a facade in another package, it needs to a single point of entry. So the facade, for example, let's think of it a simple example. Say you have a package of to record your sales data, and one of the classes in that package is going to be all the orders that you've received. The facade could well contain a collection of all those orders. So you've got an individual order class in that package, and a facade which contains the collection of those orders, which it goes off to get from a database. But because you want a single point of entry into that facade, because it's got the collection of the data. If you had multiple facades in that single package, there's a chance that that collection of data will get out of sync. One collection might have 3 orders, the other collection might have 4 orders. So by making it a singleton, you know you've got one collection of data which is mapped to a database, and therefore you've got you can rely on the number of orders that that facade is containing, which in turn points off to the order class. So that's the idea behind using the singleton in combination with the facade in that particular case, for data integrity, essentially. Does that make sense?
I think so. Let's see if our member have any other questions around it. Anyway, we do have, yeah, so RTNC actually said it makes sense. He thanks you for your answer, actually. Okay. People are also saying thank you to Venkat about the explanations for the functional programming. So we have another question here from SM Quistea, asking what's the difference between factory method and abstract factory method?
I believe abstract is more about families of creating in a family rather than just individual one-off objects. So a simple factory method is determining in one way or the other what object type do I need to return. Whereas an abstract factory, typically you've got families of objects that you're returning. So in the book I use the example of, for abstract factory, the differences are between cars and vans. They're both motor vehicles, they both have windows, they both have chassis, they both have wheels, they both have engines, but you're going to have a different family of those for cars compared to a different family for vans. So a car's going to have its own car chassis, a van's going to have a van chassis. A car's going to have car windows and a van's going to have van windows. So if you're constructing a vehicle, you want to, in a simplified way, be able to construct all of the components that you need, all the objects that you need, based on that family. You say, I want a set of car objects, and the abstract factory goes away and constructs all of the car components. Or I want a van built, and it goes away and constructs all of the van component objects for you. Just by saying once, I want a car, and let the abstract factory do all the work of returning the whole family of objects. So I think that's really one of the main differences, this sort of family aspect to a collection of objects that all are related in some way, as opposed to constructing just single objects based on some criteria.
Cool. Ivan, do you have other questions there?
Right. We don't have anything in IRC now.
Yeah, we have a couple of more, but I know that you have other things that you want to ask for. So
no, come on, let's ask the questions by the audience.
Okay. So another question that we have is also from RZNZ, asking what's the fundamental difference between a factory and a builder pattern?
I think a factory tends to just is a way of constructing an object based on some criteria. Builder is more used for when you have step-by-step processes, or at least that's one use of a builder. You've got to do this, then you've got to do that, then you've got to do a third thing, then a fourth thing. And by the end of that process, you've built something. So it's like a step-by-step process that leads you to a result. A factory tends to be, oh, I need this, I'll give you this in return. Or this combination of arguments means I need to give you that in return. So I think the main difference is builder gives you a step-by-step end result, whereas factory just decides, based on all the criteria, just give you this. A lot of these patterns, of course, are interchangeable. You could find situations where you could interchange factory for builder, and you'd come up with a reasonable solution. But I think typically there are these subtle differences that help you to determine you might sway one way rather than the other.
Okay, so Dimitri from our audience is asking if Factory is actually a one-step builder.
Yes, you could look at it like that. Yes, well, yes.
Cool. So, still regarding facade patterns, we have a question here for SEM Christe asking, for each model or package, it's worth to have a facade pattern implemented there?
Yes, I think that's one approach you can use to help simplify your system. So going back to this example where you've got separate packages for, say, one package for sales, one package for purchases, one package for order fulfillment. Each package is going to have lots of classes in it, and you want to make that package and all of those classes as easy to use as possible. So the idea behind a facade is it's a single point of entry. You get a reference to an object of that type, and that facade class will have defined within it a number of methods. One of them in the order class might be add a new order. One of them might be return a collection of all the orders within a certain date range. So rather than outside packages going directly to the order class and asking for that information to add a new order or return a collection, it asks the facade to do it for it. That gives a layer of indirection which helps to simplify it from the perspective of the outside class, because it knows it can only go to this object, this facade object, so you don't have to worry about all the intricate details of how behind the scenes the order package works. You just call the add order method of the facade, you pass it the criteria of all the orders of that order you'll want to add, and that behind the scenes takes care of all the donkey work of creating that order, generating all the database records or whatever. So it's the idea of the facade is to simplify it from the outside world.
Cool. So, and then we have a question here from Anne, who's asking, when will you use helper class over services or interface?
Sorry, could you repeat that question, please?
Sorry. The question is, when will you use helper class over services or an interface?
A helper class. I suppose a helper class is really it depends what the person means by helper class. Do they mean it's just a set of utilities?
Yeah, let's see it like that way.
Most probably it's that. I mean, I understand it that way as well.
Yes. So I think if you just want a set of utilities, then a helper class seems a reasonable way of going about it. Perhaps thinking about the math class in Java, where it gives you these various mathematical functions, that could be viewed as a helper class. I think if you think in terms of service providers, then really typically you have multiple service providers that correspond to a particular API. In other words, you have multiple ways of achieving the same thing. Whereas helpers tend to be just utilities that help you solve a particular problem rather than different ways of solving the same problem. So I think there is a difference. I think there is a difference there. The service provider is more, this is one, take database connections, for example. You have the different database drivers. So a JDBC driver is like a service provider as a layer that lets you connect to the ODBC, but you can have other drivers to connect to other databases. So it's a different service provider. So I think the difference really is that service providers are often where there's the potential for multiple implementations, whereas helper classes tend to be a single implementation.
Cool. Ivan, can you go and ask some of your questions as well?
Yeah, sure. My pleasure. Okay, the bridge pattern. I remember when I was reading the original Gang of Four book. The bridge pattern was the hardest for me to grasp of them all, even harder than the visitor pattern.
Okay.
So, would you please give us an example of the bridge pattern in the current JDK or in a well-known project, and tell us exactly which part of the classes there are part of the abstraction part and the implementation part?
Okay, that's a good question, and it's a tricky one to answer. I would say bridge classes. I just used the example of JDBC talking previously a few minutes ago, and driver classes are often constructed using the bridge pattern. So JDBC can be viewed. I haven't looked behind the scenes at how Java have actually implemented the JDBC, but drivers are often coded using the bridge pattern. So you've got the connection of JDBC, which is the Java layer over ODBC, and translating the calls between them. So the abstraction is, I suppose, the ODBC, and the implementation is the JDBC, or perhaps vice versa. I think I'd have to look in more detail in how it's actually done behind the scenes, but that might be one area in which you could look to see whether that's used. Admittedly, I think bridge is, yeah, I mean, you're right, it's not so readily used as so many others. But I think driver software tends to be one place where it could be used.
Okay, and would you consider the API SPI construction an implementation of the bridge pattern, or not really?
It could be. It could be. Like I said earlier, the service provider is often used when there is the potential for multiple implementations. Whereas bridge, there might only be the one. But then again, you might have bridges where there are multiple. So a lot of these things, you are going to find an overlap in certain situations. And that's fine. I don't think there's any hard and fast rules here. So I think to answer your question, yes, it could be in some situations.
So we have a question here from Dimitri, and he's asking us let me see if I can find the question. Okay, here we go. There are 23 patterns in the original Gang of Four books. Is there any candidate for a 24th pattern?
I think since that book has been written, things have moved on. MVC would be an obvious candidate to me, and my book includes that, plus a couple of other ones which I thought would be just useful to include. The 23 is viewed as the ones that just came from the book, because that was the originating book in terms of software, and so there just happened to be 23. People have new patterns. There are some patterns that are specific to the enterprise version of Java. So if I was to choose to add a 24, we put MVC as it. But at the end of the day, there are however many that there are. So I don't think it matters too much how many there are. It's however many are useful.
Cool. Ivan?
It's me again?
Yeah.
Okay. So I have a slightly general question on the flyweight pattern. When would you use the flyweight pattern in a project? Is it only when the object creation is expensive, or maybe there might be a different reason for that? And can you give us an example?
Well, I'm going to be honest, I've never used the flyweight pattern, except when I was writing the book and thinking, what example can I find? So the example was slightly contrived, where I just said, imagine that this was an expensive operation. So as for actual uses of flyweight, yeah, it's hard. It's one of those ones that's harder to find practical examples of. It's there in case you need it, I think. But like I said, I think it's so rarely used. I wouldn't worry too much about it. I've got by all these years without worrying about it. So perhaps we can leave it like that.
And Venkat, what do you think?
One example where I've actually used flyweight is I've done projects where we have a large volume of objects, but each object has a very common set of shared properties. This comes from fields in engineering. For example, material strength, for instance. You might have different components on your hand, but while you have different, without getting to the domain, I'll give you an example. We have people, so you have a name, I have a name, and so we're all different objects. But there are some shared characteristics we all have as humans ourselves. And I could keep that data in you, I could keep the data in me, but that's kind of pointless to duplicate the data in all these different places, which is what we have done in engineering applications where we have thousands and thousands of instances of components, but a lot of shared properties of components, material characteristics of components, we normally put them in a flyweight. So why would we want to keep them in a flyweight? Because redundancy doesn't help in memory usage, for example. So on one hand, it's objects around memory when all these data are really the same, so common properties, I would move them to flyweights. That's where I've actually used it in applications.
Cool, thank you. Hey Venkat, do you mind stop sharing your screen so we can actually see you?
Sure.
We're almost done with the session for today. I'm gonna go with one more last question for Martin Z again. I think it's actually a very interesting question, and actually for both Tony and Venkat, so I'll start with Venkat. Which design patterns do you see being overly abused, and why?
I would say not just which design pattern, I would actually say design patterns in general are being overly abused and used, and I'll tell you why that is the case. I'm not a fan of design patterns in general. And don't get me wrong, we all use patterns, we have to use patterns. But the problem I see with design patterns oftentimes is we have this desire to say, which pattern can I fit in to the problem on hand? But what I found to be useful is rather than asking what pattern to use, if I can step back and ask, what's the force in this particular design that I'm really trying to address and understand? And I value design principles a lot more than design patterns. So for example, almost every design pattern I look at, I first ask the question, what are the design principles that are a force behind these particular patterns? For example, if you look at abstract factory or factory method, the force behind them is open-closed principle. On the other hand, if you look at patterns like composite pattern, the force behind them is Liskov substitution principle. So when you think about these from the principle point of view rather than pattern point of view, then when you have a problem on your hand, you can ask what design principle plays a vital role here. So rather than trying to take a problem and match a pattern with it, I often tend to take a problem and match a principle with it. Then I go for what principle is the root principle behind a pattern, And I often get to the principle pattern through the principles rather than trying to get the pattern through an arbitrary matching of patterns. So generally speaking, I tend to really postpone applying patterns until I understand the problem and the principles behind the problem, and then I approach patterns after that.
Cool. Thank you so much. That very much
Okay.
makes sense. And for Tony, the same question to you. So,
Yes, I
do
very much agree with Venkat on that. That there can be a danger of trying to apply a pattern where you don't need to. When I'm coding, what I tend to do is write something very simple and basic, and sometimes it becomes overly complex, and then I do refactoring. And it's when I'm refactoring that I then start to think, well, what's the best way of coding this to achieve this result? What pattern could fit in, or what other way could fit in? So yes, there is absolutely a danger of you just using patterns just because they're there. They're very useful constructs. They're indispensable. They're an indispensable tool for us as programmers. But let's not fall into the trap of using them where we don't need to use them. Perhaps I can twist that question on its head and answer the reverse as well. Are there patterns that aren't used enough? And I possibly say in some factories, I think there's some cases where using factories to construct your objects might be a better way than using the new keyword, because the factory gives you more control over when and what gets constructed. So I think whilst some patterns are getting overused, there are probably some other patterns that are being underused.
and then we have like the discussion of anti-patterns, but that's like a whole different thing.
Yes.
Okay, guys, I think we're pretty much done with our session today. It's 1 hour now. I would like to thank you so much for Tony and Venkat for both of you being here with us today. We intend to make a couple of more sessions regarding the design patterns book and keep discussing the patterns. So we will love both of you to join us if you could on our next session. We haven't scheduled it yet, but probably like in 2 weeks or something.
Okay.
So if you guys are available, we would love to have you back.
Okay, thank you.
Yes?
It's been good to be here. Good to be here today.
Awesome. Thank you so much. Ivan, any last
Yeah, I'd
words
like
from you?
also to thank everybody. Yeah, thanks everybody. Thanks Tony and Venkat for joining our session today. And thanks all our audience for being so active. I couldn't ask all of my questions, which is great. I don't want to hijack this session. So yeah, see you next time.
Thank you for
Yeah,
having me.
so we also have a couple of other questions that we have it on IRC. We're going to save them for the next session. And you can see a replay of this session on our VJug website. That's virtualjug.com. And look at Twitter for the next sessions and also Meetup as well. So thank you so much, guys, and see you next time. Bye-bye.
Thank you.
Thank you.
Bye-bye.
Bye.